welcome to another edition of Maths Not Live. This is especially for children that are going into Key Stage 3 or in their first year of Key Stage 3, so going from Year 6 into Year 7 or have already been in Year 7. We're looking at Pythagoras Theorem today. It was really interesting looking this up because a lot of flashbacks came from secondary school. And you guys were a lot more advanced than when I was at school. You know, we didn't really learn this till sort of Year 8, Year 9. So it's really, really cool that I get to teach this to you. Okay, Pythagoras' Theorem. It's one of those things that you need to remember, one of those elements of maths, just like area and circumference of a circle. It's just one of the things you need to keep on board. Now, where did it come from? Many, many, many years ago, centuries, okay? Obviously, scientists and mathematicians explore the realms of what you can do in the world. You know, we know like gravity and area and things like that. You can tell I'm not an expert on this, but I'll try my best. They recognise that in a right-angled triangle, any size right-angled triangle, that if you draw a square coming off the sides, so if you draw a square with equal length on this side, I know it looks a bit more like a rectangle, I'll try and make it a bit more accurate. So if you draw a square on this side, not a rectangle, and then you draw another square here, okay, they found that the area of this square plus the area of this square actually gave you the area of the square here. Okay, so this area plus this area automatically told you what this area was going to be. Now, Pythagoras' theorem is linked to triangles, only right-angled triangles. And that is what it's doing. It's telling you, you get a formula, algebra, for this side of the right-angled triangle. Now, this side of the right-angled triangle has a very, very special name. This side here is called the hypothenuse. The hypothenuse. Hopefully I'm spelling it right. The hypothenuse. And it's because of that equation, it's that special side that can be worked out with a formula. I bet I've not spelled that right. You're going to have to check for me. So, the formula is, if we call this A, and we call this B, and we call this side C, the hypotenuse is called C, the way to find it out is, as we see it, is A squared, because remember we had a square on this side, plus B squared, because we have a square on this side, equals, those two together make the size of the square over here. So let me show you an example, a calculation example, and that should all put it together. We've got a right-angled triangle. Okay, got a right-angled triangle. If this side was 5 centimetres and this side was 4 centimetres, you'd be asked, what is the length of this side? And as you can see, it's not a perimeter question because you would have been given the perimeter of that side. It's not possible to just look at the numbers or draw any other lines to find it out. You have to use the formula. So let's apply these numbers to the formula, remembering that this side is A, this side is B, and this side is C. So we look for A. A is 5. So we've got 5 plus 4 will give us C. But it's not just 5 plus 4. It's A squared, so it's 5 squared, plus 4 squared. That will give us C squared. Right, so what is 5 squared? 5 5s. Remember, squaring is when you times the number by itself. 5 5s are 25, plus 4 squared. 4 4s are 16. Okay. And when you add those together, you will get the squared number. That will give you 41. Okay, so 25 plus 16 is 41. But remember, these are all the squared numbers. 41 is not our answer. Why is 41 not our answer? Because A is 5, B is 4, and C is this missing number. Can you see that A is not 25, B is not 16? It's the square root of the number. So what you have to do to 41 is find out which number times by itself is 41. Because as you can see, if you put 41 there, that can't be right. If this side is 5 and this side is 4, 41 is way, way too big. So because you've squared A and B, you have to find what number was C squared by to make 41. That is called finding the square root. So for example, the square root of 9 is 3 because you did 3 times 3 equals 9. The square root of 36 is 6 because 6 times 6 is 36. It's a bit like factors and multiples. Okay, so what you need to do, the square root sign, it looks a bit like the bus stop on a calculator, and you are permitted to use a calculator when you're doing these questions because a lot of the time it goes into decimals, so this would normally be on a calculator paper. So if you put into a calculator or even into Google, what is the square root of 41, your answer is 6.4. So this is 5, this is 4, and this side will be 6.4 centimetres, which you can tell works because the hypothenuse is the longest side of the right angled triangle. So it's longer than the height. Okay, I'll do another one. Because I know some of you will be thinking, what? But, you know, you'll practice this and you'll get used to it. I've just ripped out part of the triangle. So let's put some different numbers in. There we go. Let's put some different numbers in. Let's try 7 and 5. I'm not going to put meters, centimetres, that's not as important. It's remembering the method. So, A squared, this is A, B and C. A squared, A is 7, 7 sevens are 49. Plus B squared, B is 5, so we do 5 times 5, which is 25. And that will give us the answer C squared. Not C, it'll give us C squared, which is 74. Okay, but we don't want C squared. We don't write 74 here. We need to find the square root of 74. What number times by itself is 74? Again, so we'd use a calculator, we'd use or Google, what is the square root of 74? In secondary school, you'll have these special scientific mathematic calculators which will help you with that. So you type in what is the square root of 74, and it is 8.6. So 8.6 to 1 decimal place. It's a longer number, but it'll normally say to 1 or 2 decimal places. 8.6 with extra decimals squared is 74. So C is 8.6. So again, you can see it's a little bit longer. The hypothenuse is little bit longer than this side. Now, last part, okay? Because as you know, with area and perimeter, it's not always that simple. You're not always just given the 2 sides or the 1 side and say, hey, what's the area, what's the perimeter? We know from doing quadrilaterals, sometimes you're given the area and you're given the length of one side and you're asked to find what the length of the other side is, and you need to do the inverse. And that can be exactly what happens on here. I'm going to keep that green pen actually. So you could be given that this side is 12.8, so the hypotenuse is 12.8, and you could be given that this side is 8, and we need to know what A is. Okay, so here it'll be 12.8 plus 8, and we don't know what A is. So what do we do? What do we do? Right, we have to square both of these numbers to put it into the formula. So we know that 8 8s are 64, A squared plus 8 squared is 64 equals, now 12.8 squared is 163.8. I thought I'd do those in advance so I'm not on my calculator while you're supposed to be learning. Right, so you've got A squared, you've got B squared, which is 64, and you've been given C squared, which is 163. How do we now find out what A is? Something plus 64 equals 163.8. We subtract. So we do 163, think my pen's giving up in the heat. Take away 64. Running out of room here. So 8 take away nothing is 8. So 13, 12, 11, 10, 9. 15, 14, 13, 12, 11, 10, 9. So it's 99.8, but that is a squared. So we now need to find the square root of a. What numbers times by itself make 99.8? That is the challenge I'm going to give you for the end of this lesson, as well as putting a challenge worksheet up with this lesson when I put it onto the Facebook page, and it's also going to go onto YouTube. Your challenge though in the lesson is see if you can find, either using Google or using a calculator, what is the square root of 99.8, and when you found that out, that will give you the length of the missing side A. That is Pythagoras' theorem. A squared, this side squared, plus this side, square it, gives you this side squared. Okay, I hope that was helpful, and I'll see you soon. Try the challenge question. Bye bye.